Yesterday, last class, I have clubbed both the batches. There I am in different portion, here I am in different portion. That problem was there. Today, I thought of starting fluid mechanics from where I left. But once again, this where I was teaching, you will forget that. That fear I have. So today what I'm going to do, I'm going to complete the part of that calorimetry. A bit of this is remaining, expansion in solids that I will teach. And then I will move to fluid mechanics. Even if I'm not able to move it today, I'll keep a separate class where I'm going to teach fluid mechanics to you, the remaining portion about capillarity, surface tension, bubbles, and drops, all these things. So one day I need, 1.5 hours I need to complete the portions of fluid mechanics itself. Don't worry, I'll do that. But parallelly, since we started this chapter, let us see today what we can move. If I remember, last class we stopped with this question, if I'm right, isn't it? This is the question which I gave to you. I don't know whether you solved this question or not, but this is the question where we stopped the class, isn't it? So let me keep it down. Yes. Whether you solved it and tried to get the answer for this? Anybody in the class? Yeah, could you get the answer for this?
Sir, yes, sir.
Okay, what is the answer, Shrish?
Sir, 1 minute, sir. I'll check, sir.
Okay, actually, but did you solve this question? The question, my question to you is whether you got the answer for this question. See, calorimetry, believe me, is very simple if you crack the concept of it. Otherwise, it is hell. You will leave the question of calorimetry and come in the examination, whether it is school exam or NEET or JEE. If you are not understanding calorimetry well, you will hate it. You will leave it in the exam and come. So practice is the only key. Theoretically, I taught you. Principle of calorimetry is heat gained by a cold body is equal to heat lost by a hot body. And then I taught to you that if there is a change in temperature, state will not change. Change in state, temperature will not change. And if it is change in temperature, heat energy can be found out by Q is equal to mc delta T. If it is change in state, we will use Q is equal to ml. I taught this to you. Looks very simple, but questions can haunt you if you are not understanding it well. That's why I gave a question, a single question I gave. You should have tried it, then you will understand what are the difficulties in this. Anyhow, today we will do this question. And before I start talking about this question, I am just giving a very quick recap where I am going to talk about whatever I taught in the previous class. I'm talking about calorimetry, by the way. Okay, since some of you are for the first class, without that basics, you cannot understand the question. Nothing you'll understand. So for that reason,
sir, it's 316.8 kilojoules, sir.
Come again.
316.8 kilojoules.
Maybe let us check that. If your answer is right, good. If not, we'll correct it. So in calorimetry, we are learning about how to calculate the heat energy. Okay. In thermometry, we learned about how to calculate temperature, how to convert temperature. But in calorimetry, we are dealing with heat. So how do you find how much amount of heat required for a work? For example, this question itself, if you have a glass of water, okay, and at normal temperature, it is at some 30 degrees Celsius. So you took a glass and that inside you put a water, and then you took some ice from the freezer. Ice was at -2 degrees Celsius. Suppose, took the ice from freezer, dipped in the water. What will happen? Water will become cool, isn't it? How much is the temperature of the mixture now? This kind of questions you can solve only if you know calorimetry well. That is, when they say we have 100 ml of water at 30 degrees Celsius, we add 15 grams of ice at -2 degrees Celsius. What will be the temperature of resulting mixture? This kind of questions you can solve only if you are having clarity about calorimetry. Otherwise, you cannot solve. So what I said to you in the previous class, by example, I can tell you. So first of all, remember that there are two things happening. One is change in state. Another thing is change in temperature. Whenever heat is supplied, suppose I am supplying heat to object, there are two possibilities. One thing, its temperature may increase. For example, I am having this phone. Assume it is of metal. Suppose I am having iron phone. In this phone, I'm giving some heat down. What will happen? First, the temperature will start rising, isn't it? It is at room temperature now. If I'm supplying heat from below, its temperature will start increasing, 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 increasing. After one point, it starts melting, right? So, whenever heat energy is supplied to an object, there are two possibilities. One is change in temperature, another is change in state. Always keep in your mind, if temperature is changing, state will never change. If state is changing, temperature will never change. That's why I told you in the previous class, if I am having ice at minus 12 degree, and if you are keeping it on a burner directly in some container, you are supplying some 100 degree or 200 degrees Celsius temperature, huge temperature, the ice will not start melting immediately. First, ice will come from minus 12 degree to 0 degree, because first temperature has to come to a point where it can start melting. Ice cannot melt at minus 12. Ice can melt only at 0 degree. So whatever heat energy you are supplying will be used only to convert minus 12 degree of ice to 0 degree of ice. This is called as change of temperature. State will remain same. Ice will remain ice. Then the heat that you are supplying will be used to convert 0 degree of ice to 0 degree of water. Suppose you have 300 grams of ice. The whole 300 grams of ice has to become 300 grams of water now. When this process takes place, that time 0 degree will remain 0 degree. Even I am supplying from down huge energy, it won't show in thermometer. It will remain 0 only, because ice is becoming water. Until full 300 gram of ice is converted into water, no change in temperature, it will remain 0. The moment 300 gram ice became 300 gram water, what will happen now? Start rising. Once again, what temperature you are supplying, heat energy you are supplying, it will be used to change the temperature. So 0 degree of ice will become 10 degree, 20 degree, 30 degree, 40, 50, 60, 70, 80, 90, 100. The moment the water becomes 100 degree, it cannot go beyond that, because 100 degree is the boiling point of water at normal temperature and pressure. So what will happen? Now the water starts to convert into vapor. And that time, once again, the thermometer will stuck 100. What are you to supply? You are supplying heat, not showing in temperature in the thermometer. 100 means 100 only. Until all of the water becomes vapor. So once again, when state is changing, there is no change in temperature. Yeah. Yes. No, temperature will remain constant for that material. For example, I am using ice. So for water, I am having 0 degree and 100 degree. If you are having some other thing, like we have butter, so butter will have different freezing point, different boiling point. If you have some oil, it will have different freezing point, different boiling point. But suppose a particular thing has a boiling point of 150 degrees Celsius. So it will go from 0 to 150, then it will start evaporating. Are you getting? So it's not about water only has at 0 or 100. Different materials will have different below point, that is upper point and lower point. Based upon that, it changes. Okay. So the formula is, if you want to convert, if you want to find the heat during change of temperature, then the formula is Q is equal to MC delta T. In the last class itself, I told you this thing. This formula is used whenever you want to find the heat energy required to change the temperature. The formula is MC delta T. M is the mass of the substance. C is called as what? Specific heat of the substance. Again, it is a material dependent quantity. Water will have something, ice will have something, oil will have something, spirit will have something. So different materials will have different specific heat capacity. And delta T is change in temperature. Suppose they ask you, water at 30 degree, how much heat energy is required to make it at 70 degree? You can find with this formula. Mass of water should be known to you. C of water is 4186. And then delta T will be from 30 to 70, 40. Delta T is change in temperature. 70 minus 30 becomes 40. Put here, get the value of Q. I hope it is clear to you. Same way, If you want to find heat means I'm talking about heat energy, obviously. So if you want to find heat energy during change of state, then what formula you're going to use? Q is equal to ml. It can be mlf or mlv. If it is fusing means you are changing from solid to liquid, it will be mlf. If it is becoming from liquid to vapor, it will be mlv. So latent heat is different for different materials. They will give the value of this. By that, if you multiply by the mass of substance, you'll get energy required to change its state without changing the temperature. For substance, exactly. So heat during changing temperature, what will happen here? State will remain same. State remains same. And whenever your change of state is happening, temperature remains same. Temperature remains same. Is it clear to you? Any problem in this? These two things I have taught in the previous class itself to you, and the numerical that I gave in the previous class can be solved only if you are having 100% clarity of this topic. Okay? Principle of calorimetry, what it says? Principle of calorimetry says that, it says that heat gained by one substance is always equal to heat lost by other substance. Okay, what does it mean? It means that, suppose, again, same simple example, water is there in a glass, adding ice. Water is at 30 degree. Ice is at, suppose, 0 degree or minus 2 degree, whatever. So, a cold body has to gain energy to become hotter, and a hot body should lose energy to become cooler. So, in this case, who is gaining heat? Ice is gaining heat. Who is losing heat? Water is losing heat. Since water is losing heat, it is becoming cold. Since ice is gaining heat, it is becoming water. Are you getting? So your temperature of water will reduce. You kept it 30 degrees Celsius, but it lost some heat. So it came to some 6 or 7 or 8 degrees Celsius, which you are drinking as chilled water. I hope you're understanding my point. So now, with this concept, that is NC delta T, ml, and heat gained is equal to heat lost, let us go back to the previous question and let us try to solve it. Okay. So this was the question. Question was, when 0.15 kg of ice at 0 degree is mixed with 0.3 kg of water at 50 degree in a container, resulting temperature is 6.7 degrees Celsius. Calculate the heat of fusion of ice. So I'll do one thing. These two things I'll move somewhere. And we'll solve this question. Let me copy it and let me paste it. Yeah, possible. Same way, I'll take this and let me copy it and let me paste it. Okay. So now let me go to this question. I can delete this. Undo. Yeah, thank God. All things have clubbed, huh? Yeah. Yes. This is the question that I gave in the previous class. I'll solve it now for you. Please pay attention. Simple question only, but it requires some thinking. So what was given? They told that there is some ice. How much ice is there? We have 0.15 kg of ice. So mass of the ice is 0.15 kilogram. And what is the temperature of ice? It is at 0 degrees Celsius. And it is mixed with what? With water. And how much is the water? Mass of water is given as 0.3 kg. And at what temperature it is there? At 50 degrees Celsius. They told that when you are mixing it, then the resulting temperature, when I am mixing the ice with water, then its temperature became 6.7 degrees Celsius. What they're asking you to find? Latent heat of fusion of the ice. Is the question clear first? Question is, you have 0.15 kg of ice, you are dropping in 0.3 kg of water. Ice is at 0 degree, water is at 50 degree. After you add it, what is the resulting temperature of the mixture? Okay, temperature of the mixture. Okay. Sorry, that they gave. They're asking to find latent rate of fusion. Okay, let us see what will happen. So I think you understand by the principle of calorimetry, when the moment we add the ice in water, what will happen first? Ice will become water. So step 1 will be 0.15 kg of ice will turn into 0.15 kg of water. Then 0.15 kg of water at 0 degree will become 0.15 kg of water at 6.7 degree. Final temperature of mixture is how much? 6.7. So ice, let me talk only about ice, because ice is going to gain the heat energy, right? So how much heat energy it will gain? First is amount of heat energy required to change its state from 0 degree of ice to 0 degree of water. Then amount of heat energy required to change the 0 degree water to 6.7 degree water. You get some value? And that must be equal to heat lost by the water to change from 50 degrees Celsius to 6.7 degrees Celsius. You will equate both, you will get the answer. So I will repeat this. Heat gained by whom? By ice. How to find that? It will become equal to m of the ice into L of the ice, LF of the ice, plus m of the ice into C of the ice into delta T. Am I right? And what is the heat lost? Heat lost by the water. What will be that? That is will become equal to m of the water into C of the water and changing temperature of the water. Obviously, this is for ice. They both must be same. If anybody has doubt, feel free to ask me, because without understanding this concept, you will always have trouble in this kind of question. What happened, Raghav? See, ice is at what temperature, man? How much ice is there? First, the moment you put in water, what will happen to it? Water. Will temperature change that time? No. State is changing, right? So what will happen first? First, 150 gram of ice will become 150 gram of water. How to find that heat energy? ml. So that's why I wrote m into L. And then water at 0 degrees there. It has to become water at 6.7, because when we are mixing it, final temperature is 6.7 degree. So how to find that? mc delta T, because temperature is changing. This is the total heat gained by the ice. How much it lost by the water? Water was at 50 degree. It came at 6.7 degree. So what changed? Temperature alone changed. State changes there here? No. So mc delta T will help you to find how much heat is lost by the water. Is it clear? So as per principle of calorimetry, what will happen? These two will be same, and directly writing.
Changing to 6.7. Heat capacity should take it as water's heat capacity.
Obviously, yes. Because actually I should not write ice itself here. Ice became water now, isn't it? So I should, whatever. For understanding only I'm writing here. So let me write the values. M of ice is how much? 0.15 into LF only you're going to find. Plus, what is this 0.15 again? Into what is C of ice? Oh, that will become water. 4186 into delta T is how much? 6.7, isn't it? 0 to 6.7 must be equal to mc delta T. What is the mass of water? 0.3 kg into C of water, 4186 into delta T of water, 50 minus 6.7. How much is that? 43.3. Am I right? Yes. If you are having basic addition, multiplication, subtraction knowledge, answer you are saying. Oh, now only you found 43.3. Very good. 50 minus 6.7, you took 1 decade to get the answer. Great. Anyhow, when you multiply these three, 0.15 LF will become equal to this minus this. Since somebody told the answer, let me verify it, and I can always use calculator because I am not a student, but you cannot use in the examination. Anyhow, my calculator is somewhere. Yeah.
Sir,
Yes, man.
sir, in the for a C of IC you put 4186, sir.
Yes, man.
But it's not 2100 now, sir.
Is it so?
So, no, sir, I'm asking, sir.
Ice became water, no, man. The moment you are, see here, M ice
Yes.
into LF. When you multiplying these two, what is happening? Your 150 gram of ice is becoming 150 gram of water, is it? So
Yes.
now we will use waters only, no? If it is confusing you, I'll change this to water itself. Why to confuse you?
Yes, sir, I understand.
Understood?
Yes, sir.
Okay. So let me use calculator once again. Yeah. So 0.15, 0.15 times 4186. Not very good in that. 0.15 times 4186 times, what is that? 6.7. You're also waiting for me to tell by calculator, not doing by yourself. Man, you will not have anything in the exam like this. Minus 4206.93. And this is how much? 0.3 times 4186 times 43.3. How much is that? Very big value. 54376.14. In this, we'll subtract 4206.93. Some value I'm getting. I will divide this by 0.15. I am going to get 334461.4, approximately 3.3 times 1, 2, 3, 4, 5, 10 power 5. Obviously, joule per kg. Got it? If there is any problem in this solution, feel free to ask me. Anybody, online, offline, anybody has any problem in this, you can ask me. Again, I'm repeating, without understanding these things, the complex questions will trouble you. If it is clear, I'll go to the next question. To confirm you have understood everything very fine, I'll go to the next question. Pritish, understood? Sure. Gaina, what about you understanding? Tanisha, you understood this?
Explain it again, sir.
Good, Shweta. Let me explain once again. So what we are doing, we are adding 150 gram of ice into 300 gram of water, and we are coming to know that resulting temperature of the mixture is how much? 6.7 degrees Celsius. Right, Shweta? You have to be unmute for some time, please. Please
Yes,
unmute.
sir.
So what we are doing? We are adding 150 gram of ice into 300 gram of water, and we are seeing that water, which was at 50 degree, now became 6.7 degree. Am I right?
Yes, sir.
So ice would have gained heat because it is at low temperature, and water would have lost heat. Do you agree with this first?
Yes, sir.
Okay. Now ice is gaining heat. How you should calculate that? Ice at 0 degree first will become water at 0 degree, right, Shweta?
Yes, sir.
So for making ice from 0 degree to water at 0 degree, what formula we will use? Latent heat formula, which is MLF, right?
Yes, sir.
And once again, ice at 0 degree will become, sorry, water at 0 degree will become water at 6.7 degree. Understand what is happening to ice. Ice first is converting its state from ice to water, and then once again, water at 0 degree is becoming water at 6.7 degree. Are you getting this, Shweta?
Yes, sir.
So I am writing MC delta T for that. Okay. For the second part, that is when the water is converting from 0 degree to 6.7 degree. This is the energy loss gained by the ice. Who lost the energy? Water lost the energy, because water was at what temperature? 50 degrees Celsius. To where it came? 6.7 degrees Celsius. there is a change in temperature. Which formula we will use? MC delta T. So I'm using MC delta T to find how much energy the water has lost. And both these energies must be same, because that's what principle of calorimetry says. It says that how much energy one body is gaining, same energy another body is losing. So when I equate both the equations, I am getting this answer. But I hope you understood. If you have problem, still please ask me.
Yes, sir. I understood, sir.
Okay. Anybody else? You have any difficulty in this question? Please ask me. Or shall I go to the next question? 2 minutes. Okay, 1 minute. And there are very interesting questions in NEET and JEE from this topic. Very interesting questions are there. That will fully check your knowledge of calorimetry. I always like this topic in this chapter, calorimetry, because it makes you to think a bit rather than just mugging up and knowing the formula. Right. Shall I go to the next question? Mr. Raghav. Shall I go? Thank you. Yes, next question is this. Solve 10.14. This is from NCERT only I am taking. Nowhere else. This question is from NCERT. Very good question is this 10.14. You give a try. If you're not able to see it clearly, I think those who are having NCERT book can use your book also. Otherwise, if you're able to see it clearly, please go ahead. Question is in front of you. In an experiment on the specific heat of a metal, 0.2 kg block of metal at 150 degrees Celsius is dropped in a copper calorimeter of water equivalent 0.05. I'll tell you what is that, meaning of that. Containing 150 centimeter cube of water at 27 degrees Celsius. Oh my God, you will have problem. Compute the specific heat of the metal. If heat losses to the surrounding are not negligible, is your answer greater or smaller than the actual value of specific heat of metal? So, first just to write the given data from this question. Extract the given data. I'll take the attendance meanwhile. Water 0.025 kg is going to give you the value of specific heat of copper. I'll talk about that once again. I'll just take out the value and tell you. They have given not density, man, volume. Volume of water they have given. They're expecting you to find the mass of water from its density formula. Density is mass by volume. Density of water is 1 gram per centimeter cube. They're expecting you to use that theory and find what is the mass of water. Not give directly. I don't know, good question this is. Yes.
Sir,
Yes, ma'am.
sir, 1 centimeter cube is equal to how much milliliter, sir?
How much meter cube? 10 to the power minus 6, no man. 1 centimeter is 10 to the power minus 2 meter. Cube of it minus 6.
Sir, no, sir, there's one conversion to liters, no, sir, milliliters.
That is like if you have 1000 centimeter cube, that will be equal to 1 liter.
Okay, sir.
Okay. Specific heat capacity of the. That's what they're asking to find, man. See what they're asking to find. Compute the specific heat of the metal. For copper, yeah, I'm checking that only. What is the value? From a table I'm taking out.
CGS one.
Mass of water is okay. 50 grams. Gram, yes, obviously. So specific heat of copper is not required for this question.
Sir, what is the latent heat of fusion for the metal, sir?
Why you want to find that, man? Here is no weather change of state is happening here.
Sir, it's changing. Oh, okay, sir. No.
Not required. They have told that 0.2 kg of block of some metal, they have not given the specific heat, at 150 degrees Celsius is dropped in a copper calorimeter. So they have told the water equivalent is 0.025 kg, means mass of the water is given as how much? 25 gram by this calorimeter plus 150 centimeter cube of water will become 150 gram of water. Total water mass is 25 gram plus 150 gram. That's all it is. So this copper calorimeter has a water equivalent of 0.025 kg. It means it translates into 25 gram of water. And it contains water also at how much degree? I mean, what is the volume? 150 centimeter cube. So how I'm writing 150 gram? Because density of any material is mass by volume. So density of water is 1 gram per centimeter cube will become equal to mass of water by volume is given 150 centimeter cube. So you will get mass of water as 150 gram. I'm doing everything in CGS unit here. So it will become 150 gram. Mass of water we got. Okay. Its temperature is 27 degrees Celsius. Okay. And see how the question is, assume there is a calorimeter. Okay. Having some water. There is a metal block dropped inside it. Metal block is at how much degree? This is at what degree? After it is dropped, what is the resulting temperature? Who is gaining heat? Who is losing heat? Metal is losing, copper is gaining. Not copper, calorimeter and water is gaining. Isn't it? Yeah, water is gaining. So water from 27 degree went to water at 40 degree. Metal at 150 degree came to metal at 40 degree. Who is gaining? This water is gaining. Who is losing? This metal is losing. So here there is no much problem because we want to find heat lost, heat gained, equate both. So heat lost by the metal, how will you find that? Heat lost I am asking first. Heat lost will be M of the metal, how much is that? 0.2 kg, isn't it? 200 grams. M. C of the metal, we don't know that. I'm writing Cm. Delta T from where to where? 150, 240, 110. Am I right? Any problem in this? This is the heat lost by whom? By the metal. And who is gaining the heat? Water is gaining the heat. heat gained by the water. How to find that? MC delta T once again. What is M? 175 gram. What is C of water? 4186 is joule per kg per degree Celsius. In CGS unit, it is 1. If you don't know, C of water is 1 gram. I mean, per whatever is the unit here, but the value is 1 in terms of calories. Okay. So I am writing it as 175 into 1 into, from where to where? 27 to 40, 13. Minus, no need of writing, man. No need of writing. Equate both to get the answer. That's all is the question. So as per principle of calorimetry, what will happen? Heat gain. Who has lost heat? 200 into C of the metal into 110 must be equal to 175 times 13. If you solve it properly, Cm will become equal to 175 times 13 divided by 200 times 110. If you solve it, I will use calculator and find it. You just check 175 into 13 divided by 200 into 110. 0.1034. 0.1034. I'll repeat that. So it is joule per kg per degree Celsius. Now it will become calorie per gram per degree Celsius. So answer is 0.1034 calorie per gram per degree Celsius. This is the answer. If you are asking, yes, not ergs you are thinking. No, in this case it is calories. Okay. So now what you are asking, Raghav? This how it came, you're asking. This 25. Yeah, see what they're told, there is a calorimeter, and this calorimeter is having a water equivalent of 0.025 kg, means this is converting into 20 to 25 grams of water. That's what they are saying. So whatever is the specific heat of water, that's all. 25 grams it is given. So any problem in this question? This is the level of question expected exam. Tell me, Shrish.
Sir, what is the answer if we do in the joules method, sir, not calories?
You have to convert into joules and check, man. I don't know the answer in that way. You have to convert and check.
Okay,
But you have to do all the conversions, but that is centimeter cube into meter cube first.
Oh, sure.
Yeah, those things, be careful. If you're doing it, you will get the answer.
Okay, sir.
Okay. Any problem in this, please ask me. If there is no problem, one final question, simple question I'll give to make you a little confident, and then I'll go to the next topic. One final question I want to give to you, a simple question I want to give to you basically to boost your confidence. Shall I give a, make it fast. Let me know when I can continue. See, again, I'm repeating this in 11th, 12th standards and all. Every class is very important. One class you are missing, then you are coming from another class. Nothing you understand. That's a reality. There is a continuity required in 11th and 12th because each topic, this topic, those who have come for the previous class, for them it's very simple. If you have not come, not understanding, it is a little complicated, it's a little vague. So I always say that don't miss the class. Please don't miss the class because in 11th and 12th, the topics are not that simple. It's not like 10th or 9th. You have to understand deeply to solve the questions. Shall I go to the next page? Raghav. Last question for this from this topic before we move to the next concept. Simple question. Just solve it. I hope it is visible to everybody who is seeing. You have to calculate the heat required to convert 3 kg of ice at minus 12 degrees Celsius to steam at 100 degrees Celsius. Very simple question. The similar question we solved in the previous class also. Very similar question we solved in the previous class also. The same question. Only the value is changing for the mass and the temperature maybe. Water is? 4186, yeah, it's constant, obviously. What is the meaning of specific heat, Tambi? Specific heat means how much heat is required to change the temperature of unit kg of substance to unit degree Celsius. If I'm having 1 kg of metal, copper, and if I'm calculating how much heat I want to supply it to increase the temperature of 1 kg of copper by 1 degree Celsius, that is called as specific heat of copper. Understood? So don't take more than 5 minutes, everybody. Don't take more than 5 minutes. Solve this honestly by yourself. Tell me the answer. Very simple question, direct question. Just find the 4 Qs, Q1, Q2, Q3, Q4. You remember? First ice to ice, then ice to water, then water to water, and water to vapor. 4 Q will be here. Q1, Q2, Q3, Q4. Because first you want to convert minus 12 degree of ice into 0 degree of ice. You will use mc delta T. Then you have to convert 0 degree of ice to 0 degree of water, MLF. Then you have to convert 0 degree of water to 100 degree of water, mc delta T. And once again, you should convert 100 degree of water to 100 degree of steam, MLV. So if you use all this formula correctly, add all the 4 values, you get the answer. Don't take more than 5 minutes, just basic multiplications and addition. Do it fast. Yes, obviously.
Why is no one the chain of temperature? They are not given the mass of the electron.
Why is that not given? Man, ice is given 3 kg. Have you got the answer? Will you get the answer? Okay. I think you are just struggling to multiply. I hope you're solving well correctly. I'll just do some part for you, but I'll not find the answer for sure, but I'll just write the equations. Check whether it is right or not. Q1 will become equal to MC delta T, which will become equal to 3 into C of ice, 2100, times minus 12 to 0, it will become 12. This much amount of joules. Q2 will be MLF, which will become equal to mass is 3 and LF is given as how much, man? No, 3.35 times 10 to the power 5. This much joules. Q3 will be MC delta T because water is becoming from 0 degree to water at 100 degree. It will be same 3. C will become 4186 now and delta T will become 100. Multiply, get the answer. Very same question we have solved in the previous class. Q4 will become once again MLV and that will be 3 times. LV is given as 2.256 times 10 to the power 6. This much joules. So if you add these 4, you will get the answer. Now basic multiplication and addition. So I hope it is clear to you how and why I am doing MC delta T, MLF, MC delta T, MLV. So first, minus 12 degree of ice has to become 0 degree of ice. We are using this formula. Then 0 degree of ice should become 0 degree of water. This formula. 0 degree of water should become 100 degree of water. This formula. Then 100 degree of water should become 100 degree of vapor. This formula. Just put everything into picture and you will be getting the answer. Q4 is, they're asking to convert the whole water into steam, right? So 100 degree of water has to become 100 degree of steam. What formula will you use? MLV, because state is changing. So M is 3. Yeah, man, that same ice is becoming water, no? How? 3 kg of ice will become 4 kg of water. Huh? Actually, to be very exact, little change will be there, but very, very, very fractional change. But it will not be much to consider it here. Okay? Somebody is asking something? Anybody has any doubt? Anybody has any doubt? Indumati, something you want to ask? Yes, please.
Sir, I'm getting the answer is 9.1.
You want me to tell the answer?
Sir, I'm getting the answer is 9.4, sir.
Let me check the answer. Where is the book? Huh? That is a book given by answer also. Answer given by the book also. 9.1 times. So this is the answer. If you are getting this answer, it is correct. The answer is, if you add all these three, Q1 plus Q2 plus Q3 plus Q4, you will get 9.1 times 10 to the power 6 joules. Right? If you are getting this answer, your answer is correct. If you are not getting this answer, some mistake you are doing in calculation. Please check your answers and correct yourself if you are getting a wrong answer. Okay. Enough of calorimetry. There are so many questions we can solve, but it is never going to end. So I'm taking a break here. Some more questions you can solve tomorrow in the practice class. And today we are going to talk about expansion, thermal expansion. So understand that expansion in the case of solids, liquids and gases are not same. I'll tell you why as the class goes. But now I am going to talk about thermal expansion in solids only. We also have liquids in this chapter itself. But let us start with solids first. So imagine you have a rod. Okay? And you are heating the rod. What will happen? It will start melting. Starts? Okay, it will become hotter then. It will melt. It will become malleable. Don't overthink. Yeah, those things will happen. But before those things happening, have you ever felt that in summer? Once again, in summer or in winter, our doors will misbehave. That is, it will become tight. It will become loose. Not felt means you are not minding these things. And when sound starts coming in the door, you will think it became old, so the sound is coming. Right? So actually, solids tend to expand when it is heated and contract when it is cooled. Common sense is there. Imagine you have solid. What are solids? Solids are having all the atoms and molecules close to each other. We are supplying heat energy. What will happen? These molecules will start moving away because they gain energy. They'll have more vibration, more oscillation. They'll move away from each other. If they are trying to move away from each other, it will lead to some expansion. I hope you're getting my point. That is the reason for expansion, not not significant expansion to see, but it is always there. That's why you would have noted this. I don't know how many of you noted these things. Railway lines. In railway lines, between two rails, they'll give some gap and they'll connect Fisher plates to tie it. There are two plates, they will tie by the two plates, but they'll give some gap. That's why the train is going, sound is coming, because it is not smoothly going on a single rail. If they want, they could have made together, no? Why are they not making? Because in summertime, in the heat time, if it expands and it is not having that gap, it will come like this. It will expand, and expansion will lead to some kind of surge, and the trains may get accident. So every rail, if you are not noted till now, go and note it hereafter. If you're going to railway line, just see that when where the railway line is joining, no, they'll give some small gap. Not only there, we have seen bridges, right? Here, Peninsular also we have bridge. Between some span of bridge, there will be a gap. In that gap, they would have kept some steel. Why they are giving that gap? That is also tend to expand. If it is expanding, that time if you are not having any gap, it will develop cracks on the bridge. Bridge will become weak. So they are giving some gap. That gap is for little bit of expansion in the bridges, in the railways, all these things are there. So whenever heat is supplied to solids, it tends to expand. And we are going to talk about this expansion only. Now, expansion can be measured in terms of length. What? Come. Expand, but they're giving some gap for that, no? It's not touching like this. Some gap is there. Go and see today. You can take a brush and remove the dust also. So you'll see some gap is there. This much gap is there actually in roads. So car also when we're driving there, some sound will come when you're crossing that point. Because there is a steel strip. Don't think simply they are put. There is a reason for that. So the reason is for allowing the expansion of the joints. It is called as expansion joints in technical terms in civil engineering. Okay, coming back. So the expansion in solids are measured in three different ways. One is called as linear expansion, which is the expansion in length. Another is called as areal expansion, also known as superficial expansion, which is the expansion in the or change in the area. And third is called as volumetric expansion, also known as cubic expansion, which is change in volume. Obviously, all three may change. Length may change, area may change, volume may change. If you are specifically talking about only length, it is called as linear expansion. If you're talking about area change, it is areal expansion. And if you're talking about volume change, it is cubic expansion or volumetric expansion. Okay. So we'll talk about all these things one by one. First, please pay attention. It was found that, suppose there was a rod taken and this rod was heated and the rod became little longer after heating. So this was the initial length L, final length L dash. So L dash will become what? L dash will become equal to L plus some extra length delta L, isn't it? Extra length is delta L. So L dash became L plus delta L. So it was found that this change in length del L is depending upon two things. One thing is change in temperature, and is very common sense. If you change more, it will have more expansion. If 40 degrees is becoming 100 degree and 40 degrees is becoming 200 degree, they will have different expansion. More heat means more expansion. Less heat means less expansion. So change in length depends upon change in temperature. At the same time, change in length also depends upon initial length. That is, if you have two wires, two rods, one rod is like this, another rod is more longer. And if you're heating both the rods for the same temperature, this will have more expansion. Common sense once again. Why? More longer rod, more molecules, more expansion. So you can see more expansion in them. Okay. So expansion, linear expansion depends upon two quantities. One is change in temperature. Next one is initial length. If I club both, I'll get delta L proportional to L delta T, right? If I want to remove the sign of proportionality, I have to add a constant. That constant is called as alpha. Alpha L delta T. Alpha has a name. Alpha is called as coefficient of linear expansion. Coefficient of linear expansion. And if they ask you what is that, define alpha. Alpha is defined as del L by L delta T. It means coefficient of linear expansion is defined as change in length per unit original length per degree rise in temperature. I'll repeat this. Coefficient of linear expansion is defined as change in length per unit original length per unit rise in temperature. Is it clear to you? Same way, I'll give time for writing. Please pay attention. Same way, if you have some area A and you are heating it, the area may become a little bigger. A dash. And what is A dash? A plus delta A. Very similar to the previous thing. It was found that change in area is proportional to change in temperature and change in area is proportional to initial area. If you combine both, change in area will become equal to or will become proportional to A delta T. If you remove proportionality, you have to add a constant, and that constant is called as beta. Beta is called as coefficient of superficial expansion or areal expansion. And what is the formula of beta? Beta will become del A by A del T. So how do you define theoretically? Coefficient of superficial expansion is defined as change in length. So change in area per unit original area per degree rise in temperature. Same way, if you have a particular volume, suppose you have a volume like this, initial volume is V, heated it, it became a little bigger. So if V dash became V plus del V. This del V is proportional to del T. Del V is proportional to original volume, but del V is proportional to V del T. So del V is equal to gamma into V into del T. This gamma is called as coefficient of cubical expansion, and gamma can be written as del V by V del T. So if they ask you define coefficient of cubical expansion, coefficient of cubical expansion is defined as change in volume per unit original volume per degree rise in temperature. If you have understood this, please copy it fast. If you have understood this, copy it fast. This is about alpha, beta, and gamma, which are coefficients of linear expansion, areal expansion, and volumetric expansion. Please copy it fast, then I'll tell one more thing to you. Make it fast, please. Okay. Online class attendance will screenshot even. Pratosh, understanding what is happening?
Yes, sir.
Sir,
Yes, tell me, man.
the network's very bad, so can I off my video?
Okay, okay. Madhuvanti, understanding what is happening?
Yes, sir.
Yes. First, let us come for the first day. We'll talk to her and we'll keep some extra classes. Okay. Have you copied it? Everybody? Can I go to the next page if you allow me? Yeah, Shrish, you are saying something?
No, I said yes.
Okay. Here everybody is done? Okay, thank you. So let me go to the next concept. 1 second. यहाँ से बोर्ड क्या हुआ? बोर्ड ऑप्टिमम वाला बोर्ड? Yes. Sorry. Yeah. So I was talking about, give the heading as the relationship between alpha, beta and gamma. Relation between alpha, beta and gamma, which are coefficient of linear expansion, coefficient of superficial expansion, and coefficient of cubic expansion or volumetric expansion. Now, please pay attention. I'll give time for copying. 5 minutes, I'll complete this small topic. So imagine you have a cube. Cube means what? Same side length. Length L, L, and L. This cube is being heated. If you heat it, initial volume was L cube. It may become a little bit changed and may become V dash is equal to L dash cube. And let me assume L dash is equal to L plus delta L. We know it very well. So we have got a new volume, L dash cube. And original volume was L cube. What is L dash, by the way? L dash is equal to L plus delta L. Now, what is delta L? Delta L, you know the formula. See in the previous page, we have delta L formula as alpha L delta T, isn't it? So I'm writing from there, delta L as alpha L delta T. Rearrange in terms, I'm getting L dash minus L is equal to alpha L delta T. Can I write like this? Or what I'm doing? This also I can write like this. L dash is equal to, I'll take L common. It will become 1 plus alpha delta T. Can I write like this? More easy. Issue terms, I'm taking L common. So 1 plus alpha delta T. L dash value I'm having. If you're having L dash value, you can now find V dash, which is equal to L dash cube, isn't it? So it will become V dash is equal to L dash is L into 1 plus alpha delta T, the whole cube. Am I right? So V dash will become equal to L cube into 1 plus alpha cube delta T cube plus 3 alpha delta T plus 2 3 alpha square delta T square. That's the formula, right?
Square plus 3 alpha square delta T. Sir, in
3 square and this thing, yeah, correct.
Sir, in PET square.
Now it's correct, no? Yes. So I have not given a question to you, then you understand. Alpha, beta, and gamma very small values, 0.00352, 0.0000655, like that. So alpha, beta, and gamma are very, very small values. Assume 0.005 itself. 0.005 if you are squaring. 0.005 if you are cubing. Why very smaller? So since alpha, I'm writing it here, since alpha is very small, alpha square or alpha cube are very, very small. So it can be neglected. Are you getting my point? My aim was to neglect it. Neglected. If I neglected, what is V dash now? V dash became L cube. This term will be neglected. This will be neglected. What I'm left over with? 1 plus A cube plus B cube. I wrote correctly, no?
He got confused.
Sure. Now it is correct or now I'm changing? Why A plus B the whole cube is what here? A cube plus B cube plus 3 A square B plus 3 AB square. So this is A into B square. That's what I did first. And one will be alpha relatively because I'm doing the square of this one square. Very good. Okay. So coming back to where we were. So I'm going to have these two terms removed. So what is going to be there? 3 alpha delta t, isn't it? Because I'm neglecting all the higher powers of alpha. Why I'm neglecting? Alpha is very, very small. Squaring it will become further small. Cubing will become further small. So V dash I got. Okay. What I'm going to do with that? I'm going to write what is gamma. What is gamma formula? Gamma formula is delta V by V delta T. Delta V by V delta T. Okay. What is delta V? I can find delta V from here. Let me write that first here. V dash is equal to V into 1 plus 3 alpha delta T. So I can write V dash is equal to, I'm opening the bracket, V plus 3V alpha delta T. V dash minus V is going to be delta V. It will become equal to 3V alpha delta T. And I'm going to get delta V is equal to 3V alpha delta T. Do you agree with me? This is the value of delta V. Why I have used this? Why I found this? Because I'm going to find gamma. Gamma is equal to del V by V delta T. Now what is del V? Check from there. 3V alpha delta T by V delta T. V delta T gets cancelled. I'm going to get from here gamma is equal to 3 times of alpha. Is it clear to you? Is it clear to you or not? I hope it is clear to you. Same way, if I would have taken initial area as A, is L square. Final area is A dash, L dash square. And I would have found L dash, then A dash. And the same way, I would have got beta as, I'm writing it here, or I'm writing here. Similarly, beta would have been come as 2 alpha. If you want, as a homework, you can go and do this. What you will do, you will take area as A, which is equal to L square, and A dash will become L dash square. L dash will become L plus delta T, alpha delta T, and just put in this formula and get the solution. Finally, you are going to get beta also as 2 alpha. So gamma is 3 alpha, beta is 2 alpha. Finally, you can write relationship between alpha, beta, gamma will become alpha by 1 is equal to beta by 2 is equal to gamma by 3. This is the relationship between alpha, beta, and gamma. Common, see here, beta is 2 alpha, gamma is 3 alpha. Isn't it? So this is the relationship between alpha, beta, and gamma. Alpha by 1 is equal to beta by 2 is equal to gamma by 3. If you have understood this, copy it fast. If you have understood this, then copy it fast. And if you want to try this beta as 2 alpha, you can try it as a homework. Very similar kind of things, but it will be more simpler because it will be a plus b the whole square there, not cube will not come. Have you copied? How beta is equal to? Understood? Okay. So, everybody has copied? Please make it fast. Already we are out of time. So, Saturday you have a math class here, right? In this room? And tomorrow is Friday. Tomorrow I have next week. Sriniketan school, what they are teaching now? Thermodynamics. Going fast. This chapter that finished. Calorimetry and all you did in school itself. Nothing understood. Now understanding something. Okay. So what about Sriniketan? Sorry, SSM school, what they're doing?
They skipped these two and then they went oscillations.
What they taught last before oscillation?
Fluids.
Fluids they taught, they skipped thermal properties, thermodynamics, kinetic theory, went to oscillation. 3 chapters they skipped. Okay. After that, what they will do? They will come back to these chapters. Oscillation. Why are they doing like that?
Because for the next one, sir, they said that oscillation and waves are important.
Seriously, who's telling that? Okay. Oscillation is not an important, wave is important. That too not much important, little only. Okay, anyhow. Which school you belong to? Sri Chaitanya, you told. What they are doing in that? You told thermodynamics. Yes, you belong to Narayana. Velamal, what they are doing? Okay. Guyana? Kinetic theory of gas. They have finished all these things. Okay, okay. That is not a talk now. Okay. Pratosh, which school you belong to, man?
SSM, sir.
Very good. Okay. So your school you told already. Any other school? What is happening in Srinivasan? Gurukulam, what they are doing? GVA.
Sir, completed thermal properties.
Okay. These things are already done in school.
Yes, sir.
Okay. Kirtish Kumar, what is your school doing? Kirtish Kumar, if you are hearing me. Or anybody else from Kirtish Kumar school, if you can say. Kirtish Kumar, you on your video but not on your mic. I think you confused and on your video. On your mic and tell me, man, what they're doing at your school. Which chapter is happening at your school? No response. Lakshika, what is happening at your school? Are you there in the class even? Please respond if you're there in the class. Sarvanaram, what is happening at your school?
Sir, they're going to start a kinetic theory, sir.
They finished thermal properties, thermodynamics, everything.
Ah, yes, sir.
Shakti Varshini, what is happening at FITG?
Sir, fluids.
Oh, they're in fluids only.
Yes.
Krishna, you are in Wales, right?
Yes, sir.
Okay, they told about your school. Okay, fine, fine. So, have you copied it? Okay, I hope you have copied it. Okay, for guys, before I close the class, one thing I want to say that whatever expansion you have learned now, I'm giving some homework to you. If you're having NCERT book, if you're not having NCERT book, download it from the internet. See, I'm also downloading and only using. So you can download and see. Homework is, I just now taught you about expansion and we learned alpha, beta, gamma, everything. So from here, fluid expansion we not learned, but yes, we learned this. So example 10.1, example 10.2, example 10.1, 10.2. Please copy down somewhere. Homework I'm giving. Example 10.1, example 10.2. From exercise also I'll give some question as a homework. From exercise 10.6, 10.7, 10.8 and 10.9. 10.6, 10.7, 10.8, 10.9. These 4 questions. So 2 examples, 4 exercise questions. Please solve in that before the next class happens. We can discuss all your doubts. Okay. 2 example I have given 10.1, 10.2 and 4 exercise question 10.